Morning. Hope I can start now. Later. Fine. Yesterday, IOT and FDM applications, how exactly IOT and FDM differs, everything has been discussed. Now we need to what exactly the applications. Somehow only two applications is explained, three applications, and how the architecture is there. The applications as per the syllabus and the textbook is given the different picture and it's not that much good. So I googled it and I put it on the slide itself. All of you know about this application. It says one of the application of your IoT is a smart watch, and all the features, almost all the features what is available in the mobile phone, all the features are available in smart watches. What are the features? Anybody is having smart watch now? You are having smart watch. Yes. I don't want to see it now. I don't want to see it. You know. You know it now. Okay. Now those who already using the smartphones, can you give some of the features of that, some unique features? Yes, that's great. Okay. Next. So you walk, you run, you exercise. How much calories you have burned? So these orders, without wasting much of the time on that, you people know that what are the different features of the smartwatch. Smartwatch, how it works. It should have an internet. It should have an internet. Without internet, you cannot do that. It's a thing. It is connected to the internet where we are able to get. As I said, since many days I am telling, I want to walk from here to Vidhan Sauda. I want to walk, or I want to, instead of walking, I need to ride my vehicle. Okay, I can switch on my smartwatch. I can come to know that one. What is the distance from here to Vidhan Sauda? It will show that one. How much time it may take? Just a GPS navigation. Okay, and what will be the traffic? What is the traffic congestion? Which way I have to travel, navigation, everything it's going to show. So it is almost similar to your mobile phone, a thing which is connected to your internet. It can get you the details itself. So it's mentioned over there where calorie is there, healthcare is there, blood sugar pressure, blood oxygen, distance, pedometer, sleep monitor, call reminder, remote camera, message pushing, all those things is coming out. Something like waterproof. It is waterproof. It should be. Okay. There is one ad is there, no? Have you seen that ad? Vim bar ad. There is a Vim bar ad. She was washing the dishes. Water falls on the smartwatch. Her cousin asked her, "Hey, water is falling." She said, "Don't worry, it's just waterproof." But the Vim bar is not a waterproof. Some advertisement. So in that one, they have mentioned that one, your smartwatch is a waterproof. His mobile is a waterproof? Yes. Can we wash the mobiles? No. Second application is smart home. I told this one many times how exactly smart home will be working. So in the smart home, basically, we will be having sensors and actuators. Last but one bench, concentrate here. Smart home, generally we will be having n number of sensors based on the requirements. Those sensors, they are going to sense the information, and based on the sensing data, they are going to actuate it. Okay? N number of sensors, different types of sensors are there. Wired and wireless sensor. Some of them are wired sensors, some of them are wireless sensors. Like security, camera, thermostat, smart plugs, lighting, entertainment, everything. Alexa is one of the example. Do it yourself. Some of the sensors they do on their own. As soon as it tells us, it switch on the light. It is not that I should go and tell that one. It is sensing an obstacle. An obstacle goes and stand in front of that one. It senses the obstacle, immediately switch on the light. So do it yourself. We'll call it DIY. Do it yourself sensors and actuators. It may be a smart plug, motion detector, door window detector, water pumping. Automatic water pumping, you might have heard about that one. A microcontroller based simple application. Okay. What it will do, it will find the level of the water. If it is getting empty up to some threshold level, it will sense it out. If the water goes below that one, immediately it pumps the water. Okay. So once it tank is filled, one more sensor is kept over there. That senses that when water is almost filling, I need to switch off the motor. Okay. So we can do that one. These are all the some of the do-it-yourself sensors and actuators they're performing on that one. Even your washing machine also, lot of sensors are there. Water pouring, water stopping, all those things is based on your sensors which are mounted in that particular system. So we will be having detector, door and window detector, smoke detector, energy meter interface. Everything can be kept in your home. So we call that a smart home. Garage open, garage door open and close. Using a remote, you are able to open and close that one itself. They are connected. Okay. And you are able to identify, you are able to check that one, whether my home is locked or not. Whether I have switched on my geyser or not. Sitting in your home, sitting in your office, you can control that one. Okay. By the time I reach my home, my geyser should heat the water so that as soon as I go home, I can take a bath with hot water. You can switch on. I can cook the food. Sitting in my home, I can switch on my cooker. By the time I reach home, I can get the hot food. So these are all the things which are connected where you are making, it is making as a smart home itself. So we are having LED lights, electricity, electric utility meters, wireless Wi-Fi speakers. Everything is connected. Everything is smart home. This is just a theory. Next image will be showing you how exactly they are connected. Okay, using in IoT services. A connected home has the following application deployed in the smart home. We will be having mobiles, tablets, IPTV, VoIP, voice over IP, telephony, video conferencing, video on demand, video surveillance, Wi-Fi and internet. All those things are available in your smart home. I am not smart enough to control the noise in the classroom. I'm getting a lot of noise. Just 20 to 30 minutes, that's more than enough. Afterwards, you are free. Just concentrate on that one. If a batsman doesn't concentrate on the ball delivery, he cannot hit the 4 or 6. Correct? If you're watching the umpire or if you're watching somebody else, same thing happens. If you don't concentrate in the classroom, you are going to struggle in your IA or even your examination. If you concentrate correctly in the classroom, hardly 10 to 15 minutes for you to read. If you don't concentrate, finally you'll scratch your head like a monkey. Fine. So these are all the devices which are available in your smart home. How exactly they are connected? Home security is one more application where access control and security alerts. Definitely it's going to alert you. Okay. If any obstacles, you are having a surveillance camera, anybody passes in front of that one, okay, definitely it's going to alert you. Lighting control, home healthcare, fire detection, leak detection, water leakage, gas leakage, it can detect it. I think the automatic gas controlling, there is one device is there. Okay, it can control the gas leakage itself. Energy efficiency, solar panel monitoring and control, that is also one of the important. Temperature monitoring and HVAC, that is for your electrical department, high voltage control, refrigerator networking with maintenance and service center, automated meter reading. All these things comes under smart home. Okay, first slide, second slide. How they are connected? This is how they are connected. So it's a image which is just taken a snap and kept it over there because I didn't find the time to draw that, or I didn't find the online image itself. So take a snap and put it in the slide. That's what I have done. But I will try to create on my own, which consumes time. Minimum one image if I draw, I want to draw this, it takes some half an hour time to do that. So let us not worry about this. So all the devices which are available in your smart home, they are at the bottom layer. I told you device layer, device, then network, then application. Okay, 3 different domains are there: device domain, network domain, and application domain. So at the bottom, all our devices are available. What are the devices? It will be a sensor, it will be actuator, everything. Okay, so we have a Zigbee, we have a wireless LAN, we have a home automation system. Okay, all home automation surveillance system, everything will be connected to smart home control unit. There is a smart home control unit should be kept in your home where it's going to control, because it's just like a gateway. It's a gateway which is connected to your IOT. IOT is there in the service. There is a cloud service over this. Because I may be having all the infrastructure in my home, but since I need to connect to an internet, it should be controlled through the internet. There should be a gateway. The gateway is smart home control unit. So we will be having UWB, GPRS, you may be having Wi-Fi, any type of communication system you will be having over there. Through Wi-Fi we can connect, through GPRS we can connect, through your UWB you can connect over there. That is different types of communication system. Then comes your VPN, virtual private network. So bottom level is at home, at the top layer is a network layer, and also your cloud layer itself. Okay, so your service provider infrastructure, somebody is providing a service, internet service provider. Who is that? I may be having a Airtel, or I may be having a Jio, or maybe having a BSNL. Don't worry, don't worry. Okay, different services they are having over there itself. What are the services? They may send an SMS. What happens? I'm having my system, my home, I made it smart home, but I forgot to switch off my geyser. I forgot to switch off my gas. Immediately, it senses, sensing gas sensing device is going to sense in my home. That will send to the internet. The service provider, he will be having SMS services. He will be sending the SMS to me through mobile. Then as soon as I got a message, being sitting in my office, I can switch off or I can control everything. So SMS service will be there from the IoT services. Email service, you may send an email also. Generally, we will be sending an email. If a simple example is your banking transaction. One banking transaction. If somebody withdraws money from my account, I given a check or I given some DD. If from my account, if some amount has been deducted, withdrawn, immediately a message comes to that one. And mail also will be sent to my mail ID. What are the mail ID I have connected? What are the contact number I have given? For the contact number, SMS will come. For the mail ID, it's going to show this much amount has been deducted. Even the amount, if it is deposited also, either debit or credit, it's going to send a mail for that one. So mailing service also will be there by the service provider. SMS service also will be there by the service provider. Similarly, billing should be there, and push notification server, IVR. All these things will be available from the service provider. In between, bottom layer, all your physical devices, top layer, all the services, that is your application, whatever the applications are there, is having all the application is going to provide that one. SMS is one application, email is one application. Everything will be done by your infrastructure provider. In between, we have to maintain all these things. We should have a database. Without database, today it is withdrawn. Tomorrow you will go and say, hey, nothing has happened, I don't know. You should maintain the database. The service provider has to maintain the database on this so and so date at so and so time. This is what has happened. So there should be a database, magic database, log database, sign certification, who is logging in, who is logging out, everything has to be taken care. I may be having a control on my home. My spouse also may be having a control on my home. If I am not operating, my spouse, she may get the data, she will get the information, emergency information, so that she can also control over it. So it should know who is signing in, who is doing that particular duty. Okay. home automation is not applicable only for one person. It can be distributed or it can be given to multiple people who are working in that country. It has so many things are happening. Some one person, he was able to call a police saying that, sir, somebody is entered into my house. Kindly look into that. I am not in the place. Okay, I am out of station. Kindly look into this. Immediately, police they came to that particular house. They could able to capture the burglar. How it is happened? It is because of the smart home. Okay, so lot of things can be done, and it is keep on updating. Video DB, log DB, magic DB. Video if you want to store, you can store it. Audio or text, everything you can store it over there. Excuse me, black shirt. Get up. Any issues? I am having some issue with you. I am having some issue with you. You want to come sit here? Try once. Come. I am getting some disturbance because of you only. You better come here. Or you can come to the front bench. Kannadadalli ಒಂದು ಗಾದೆ ಇದೆ. You know Kannada? ಬೇಡ. Yeah. So this is the infrastructure with 3 layers, 3 domains. That is your data, that is your device domain, network domain, and application. That is your application. Next, how exactly Intel is providing the service? Intel has given the service over there. So we told Cisco, IBM, Oracle, everything. Now Intel is taking care of the how you can go for a smart home. What and all the operations and applications you can go for it. Intel-based intelligent gateway enables creation of the home automation system offered by the service provider for telephony, mobile, cable, broadband, and security. Intel, it's totally, there are the, what we can call, the big industry with respect to your ICs. Okay, all the services, processors, they're manufacturing. What all the different types of processors are required for your home automation, they are providing over there. Where they can connect to mobile phones, they can connect to telephony, they can connect to cable, broadband. So Airtel, you may heard about Airtel broadband, you may heard about DSL broadband. Airtel only is not manufacturing all the devices. They are procuring the devices, components from different vendors over there. So Intel plays a very important role for providing the services for Airtel itself. They are providing the chips, ICs, and connections, everything for the broadband connectivity. Open HAB, that is home automation bus. Open home automation bus enables the smart home devices that communicate via home. So any device, generally, I think you might have studied embedded systems. Yes, you studied, no? Okay, there is bus comes into the picture. Bus is an interface. Okay, since I know embedded system, I'm talking about it. Generally, I'm having an ARM processor, I'm having a peripheral. The processor is there, peripheral is there. And these peripherals will be of different speed. Processor is of different speed. The peripheral which is connected works with different speed. The processor always will be at the high speed itself. Correct? See, simple example, I'm having a laptop, in that one processor is there. The processor will be in the form of gigahertz. In the form of 2.5 gigahertz, 2.8 gigahertz speed is working over there. But if I'm connecting an external device, I'm connecting over there. That external device is a peripheral. There is a small motor. Your microcontroller lab, if you check it out, AC motor, DC motor, they will be working with very low speed, like only 100 RPM, only not 100, even 10 RPM, or 1 second, 1 rotation. In 1 second, 1 rotation. So my device which is connected, which is working with low speed, the processor is working with high speed, but I am connecting both of them using a bus. Bus has to be connected. So the bus here is high speed bus. Here is going to be peripheral bus, we call that. It's a peripheral bus or low speed bus. This is a high-speed bus. This is a peripheral bus. In between, there is a bridge. Is there? First bridge. Bridge is going to take care of how to communicate between them. This is a highway. This is a narrow road. But in between, there is a bridge which connects over there. So why I am pointing here is there is a open app. It's a home automation bus. It has to see to that one by what speed your home automation has to be taken care. Okay, by how fast the information has to be passed, how fast the data has to be transmitted, how fast the devices has to work. Everything will be taken care by your home automation bus. It has companion cloud computing service called my.open app. It runs on Java enabled system. They work on the Java. The thing system enables the smart home devices which communicate and control via home itself. What are the things which are kept over there? Via home, we are able to communicate, we are able to control that one. And language, what we have used is Node.js, and the devices, what we have connected using a Raspberry Pi or Arduino board, we can connect over there itself. Have you done any small projects, mini projects using a Raspberry Pi or any workshops or anything you have attended? Arduino workshop you have attended? Node MC, Node.js, everything. So there are different programming languages, we can go for it. Smart cities. Till now what we have talked is smart home. Now we are going for smart city. In smart city, it is little bit enlarged. Whatever the smart home was there, it is restricted only for the home, but it should be extended for the public. It should be extended for the public. So in the smart cities, generally what happens? What is the traffic? I want to control. I want to know about the traffic itself, whether the lighting is proper or not. I am going to this particular place. How to install the new lights? How exactly it can be eliminated? Okay, there is a smart park is there. Park, a garden. A garden is there. Generally in the garden, what happens? Light should be on during the evening time, 6 to 10 o'clock. Park is open by 5 to 10 o'clock. So 5 o'clock there is no lighting is required. Only after sunlight goes down, maybe after 6 o'clock or 6:30, parking light should be on. Manually, it is not happening everything. Everything is automated. Sitting in the power station, he is going to switch on the parking lights. Or you can set the time saying that when at this time the parking light should be on. Once it is 10 o'clock, parking light should be off automatically. So these are all the requirement. Instead of going and manually switching on that one, you can sit at home and you can maintain that one. So that is what smart cities require. I have given one example of a garden. Not only a garden, street lights also. I told you, any obstacle comes in front of the street light should be on. Once it passes away from the front, light should be off. One of the professor, Dr. He was the friend of the ex-principal. Okay, I'm not finding his name. Some person is very good. He has taken some students from IAC. He has taken some students from IAC as the interns. They are all doing the MTech and PhDs. He took them some 4 or 5. Under him only they are doing the internship over there. He took them to one of the village near after Chikbalapura, after that Peresandra, after that one is that Varulkonda. Varulkonda something is there. There is a remote village. A remote village. He took them and they did some internship over there. What they did there? Smart lighting. Smart lighting system. Okay, it's a totally forest area. Inside the forest only they should go and they should reach the village over there. So what they have installed? It's a road and reach the. So this is called the highway. Okay, from the highway they should go inside some 4 or 5 kilometers and reach there. No lighting, nothing. What they need? They cannot go and request the government for installing the poles and all those things. Whatever the infrastructure was available there in the forest, they make use of that one and they install the lights. So what it is? Bamboos. They took the bamboos, they cut the bamboos for 10 feet. 7 feet, 8 feet, 9 feet, 10 feet. Okay, the bamboo has been installed. Then there is one more word. Diagonally, one more bamboo stick. Okay, make a hole in the bamboo, fix the LED lamp. Above that, fix the solar power supply. So like this, they installed over there. And they are also controlling the one. Smartly should be on. They have gone for the detecting an obstacle. Any obstacle comes, then only a light should be on. Once he has moved away from that particular light should be off. So what we can do, we can save the power. We can save the power over there. So this is already been done. I'm not getting his name. A very good person. And he came here many times. Okay, when our ex-principal was there, he has been invited for many talks and everything. No issues. So they have installed. Now also it is there. Inside the Valkonda, there is a village. The interns have installed over there. So they have not gone for the cement-based poles or steel-based poles or all chemicals. They are not used. Existing wooden poles only they have installed over there. So that is smart cities. So now the question on this one will be 4-layered structure. You should explain for the smart city. We know OSI it's a 7-layer. After that one it's been modified to 6 layers. I'm coming to that one, that is IOT and MTM based modified layers. Next topic is that only. Before that, Cisco has developed 4-layered architecture for smart cities only. Cisco has developed that one. So it's the 4-layer architecture framework developed by the Cisco for the smart city is as follows. Layer 1, layer 2, layer 3, layer 4. Layer 1 is always at the bottom. Layer 1 is always at the bottom. Layer 4 is at the top itself. Always we should go from bottom to top. Okay. So layer 1, it comes all the physical devices, it will be there itself. Sensors, sensor network, device network in parking spaces in cities. Okay. Hospital streets, hospitals, vehicles, banks, water supplies, roads, bridges, railroads, everywhere. What are all the services are available in the cities? For everywhere, they have installed the sensors and sensor networks. Okay, everywhere they have installed that one. And next, layer 2. What are the sensors you have installed? Where are all the sensors you have installed? We need to capture the data from them frequently or regularly. You have to capture the data. Assume that one during the morning 10 o'clock to evening 5 o'clock. Morning 10 o'clock to evening 5 o'clock, Vidhan Saudha and High Court is jam-packed. Obviously. Morning 10 o'clock to evening 5 o'clock, Vidhan Saudha. If not Vidhan Saudha, at least High Court is jam-packed. Vidhan Saudha we may find the people, we may not find the people, but High Court is always people will be there. Lakhs number of cases are pending. Lakhs number of cases are pending. Every day cases are increasing. One or the other cases will be there. There are n number of courts are available in High Court. High Court is not only one court. There are n number of halls are there. Each hall will be engaged in one or the other cases itself. Now, why I'm telling is I want to know what is the traffic near High Court. Okay, what is the temperature near High Court during morning to evening? What is the wireless communication system should be provided in that area during morning 10 o'clock to evening 5 o'clock. At least you will find 10,000 people nearby that. So all the 10,000 definitely they will be having mobile phones. So all the 10,000 people should have a service for the mobile. How much infrastructure should be installed over there? How many service providers? Some may be having Jio, some may be having Airtel, some may be having Vodafone, some may be having BSNL, some may be having some other. So, if more Jio customers comes, Jio has to provide increasing their service. Jio should not deny that one, no, I cannot give the service. Because nowadays, people are porting one service to other service. Take an example, forget about High Court. In our college itself, they rank 1,500 students regularly, morning 9 to evening 4 o'clock. So assume that when all of us are having Jio, everyone is having Jio. Everyone will switch on the mobile phones. Everyone will try to go for some service. Now Jio has to provide minimum 1,400 services in 1 second. How exactly they can do that? That is where smart city comes into picture. They need to provide. They need to provide the service. I'm paying. I'm paying on monthly basis. Monthly basis is there. They have already told me that one per month this is the charge. This is the charge per month. 3 months this is the charge. They are not restricted as how many calls or how many messages. They might have restricted, but if everyone switches on together, they should provide the service. Smart city plays an important role. How exactly they can provide the service for that one. So gathering the information by installing the sensors are very, very important. Layer 2 will take care of that one. Capture the data at distributed computing points where data processed, stored and analyzed. We can process, we can store and we can analyze it. Some unwanted data, we can remove it. Some noise is there. Okay, remove it. Don't worry about that one. Whichever is very important, you need to capture and you should store and you should analyze that one. Third layer, meant for central collection services, connected data centers, cloud and enterprise services for data analytics application. It is a central collection center. Here, piece by piece is collecting. Finally, it's going to be dumped in the third layer, where it's going to be a central collection center will be there. It's going to be stored. After processing, after analyzing, all those things will be dumped in the central collection center. Fourth layer consists of new innovative applications. What are the applications? Where and all you want to send? It's going to send that one. Such as waste container monitoring. One of the very big tragedy in India. Yes or no? Waste container monitoring. How many of you will throw the waste exactly at the dustbin? Only there will be a waste inside the classroom. Even there was a dustbin. I am not finding the dustbin here. Since there is no dustbin, we are keeping the dust there where and all we are sitting over there. So they want to monitor waste bins, containers, whether it is full or empty, or it's getting full. Lot of people, since many years, students are doing this project, waste management system, smart waste management system. Every batch they'll come and say, sir, IoT based waste management system, IoT based dustbin management system, IoT based dust segregating system. All wet waste should go like this, dry waste should go like this, all your Tetra Pak should go like this. IoT based. It's good. It's good. But you should see to that one how exactly they are working. Major problem in almost all the cities and places, what we have observed, waste bins, they are kept, but it's not monitored properly. Lot of issues are there, technical issues, non-technical issues are there. We have to check it out. Until we ourselves cultivate those things, I should keep the waste in the waste bin. I should throw the waste in the dustbin. Until we analyze that one, we cannot become smart. Even though n number of things comes into picture, we cannot go ahead. So smart cities, basically they have to go for waste container monitoring, power loss monitoring, how much power is getting lost. This is also one of the concern. Last person who is going out of the class, I sincerely request you people, kindly switch off the lights and fans. The person who is leaving the classroom last, a person comes first, definitely will switch on the light or switch on the fan. But the person goes out last, it is not my job. That is. So we are wasting the power. We are wasting the power like anything. So that is one of the smart city challenges. Bike sharing management. What is the bike sharing management? Which is the service provider? Bike sharing. Bounce. Bounce is a bike sharing only. I am sharing the bike. Even I can do one thing. Other bike sharing. Even Ola and others sharing only. The person will say, Ola, that one is going to share his vehicle. Means put all the money. I am the vehicle. I am two-wheeler. Morning 9 o'clock to 4 o'clock to be standing alone, like idle it's there. I can connect it to a bike sharing application. I can tell them 9 to 4 o'clock I can use this bike. Make use of it. And finally fill the petrol. That is more than enough for me. Correct? Okay. So they can make use of my vehicle and they can fill the petrol. I can share my bike. Your bounds, they are sharing the bike. They will come to know that one through GPS and all. They can identify that one who is using, at what time they are started, where exactly they are stopping, whether we can give it to somebody else also. Smart parking, one of the major issue. Smart parking refers to services for motorists that informs them about the nearby parking services. Once again, I am telling, I am very sorry. Just captured image. The 4-layer structure of your Cisco is going to be 1, 2, 3, 4. 1, 2, 3, 4. What all I explained theoretically just now, the same thing has been given here. Now the actual topic, what I told yesterday, modified OSI model for IOT and MPM. They rank 7 layers, generally they rank 7 layers, but it is being modified for IOT. 7 layers have been modified to 6 layers. Okay? How it is been modified? We are not supposed to lose anything. We should not lose any information. We should not deny any information. We should get all the data, whatever was available with respect to internet, and it is supposed to be little bit modification for the IOT and MPM itself. What exactly? OSI protocol means a family of information exchange standard developed by the ISO. What is ISO? What is OSI? Open system interconnectivity. See, this is the multiple choice questions. Generally, they'll give OSI means they'll give 4 different answers. If you give open system interconnectivity, open system interconnection, okay, like this they're going to give. You should select the proper answer over there itself. Similarly, ISO, it is not ISI. It is not ISI, it is ISO. International Organization for Standardization. International Organization for Standardization. We have to standardize each and everything. Okay. So ISO means International Organization Standardization. You cannot say International Standardization. So International Organization for Standardizing. Some standards we have to maintain. So they have introduced OSI model. Initially it is 7 layers, but for IoT and M2M, we are not using the 7 layers. We have restructured that one to 6 layers. What are the 6 layers? Gather, enrich, treat, manage, acquire, organize, and analyze. It is not 7. 1, 2, 3, 4, 5, 6. Organize and analyze is one single. Okay. So all those things comes under IoT application services. Let us see how exactly it's going to be done. I could able to draw the image. Here you can easily see that how exactly 7 layers are mapped to the 6 layers. Okay, this is the 7 layers. OSI layers. Okay, general standard OSI 7 layers. That is being changed to your IoT and MPM 6 layers over there. What exactly has been done? Some layers have been kept as it is. Some of them are merged. Some of the layers have been merged over there. See here. Physical. In OSI layer, we ran physical layer, but it has been little bit modified into physical and data link. Physical and data link. Actually, we ran physical separate and data link separate. But in IoT and M2M, the bottom layer, it is being changed into physical and data link. Then what about the second one? What is the second one here? Data acquisition. Not only linking, after linking, we should acquire the data. We are supposed to acquire the data. So what exactly it's doing? Here gathering is doing. After data link, after gathering, it has to enrich that. To enrich that, we are going to call this a data acquisition. So enriching comes in data adaptation and data acquisition. Data adaptation is going to adapt as per the requirement. Unwanted information is coming, unwanted data is there. Don't want the unwanted data. Adapt the data which is required for that. That is why enriching will call that. It's going to enrich. Next one is network layer. As it is network layer has been kept. What it will do? It will streamline where exactly it should send or from where exactly you have to receive. Different networks are there. It may be a wired network or wireless network. It may be TCP/IP. It may be UDP. It may be something else. Don't take only half-boiled. Learn fully. The person who knows everything will sit quiet. The person who doesn't know anything, they will sit quiet. Those who know in between, they will be making the noise. People generally, that is the usual tendency. Hey, I know this. I know this. That is only half point. In depth, you should know. Technologies, you should know. Theory is not sufficient. Technically, you should know. What is networking layer is going to do? It is streamlined. It is going to select which networking topology we have to use there. We may be using wired topology, we may be using wireless topology, we may be using Bluetooth, Wi-Fi, Zigbee. These are the different topologies we will be using over there. We should know what type of topology we are using. That comes under network layer. Streaming. It's going to streamline. It's going to stream the data. Whatever your data adapt, you have done that. So that will be there. Fourth layer, transport layer. Okay, transportation. Should send. So these two layers, network layer and transport layer, will take care of streamlining. Streamlining. Okay, streaming the data. Next, the fifth layer is the session layer, but session layer will not be there in your IoT and M2M. Session layer and presentation layer, both have been merged together. They have changed that one as application support layer. There is no session layer, there is no transport layer, there is presentation layer. Application support layer comes into picture, where application support layer will take care of manage, acquire, organize, and analyze. That's what I told you. 1, 2, 3, 4, 5, 6. 6 layers. It's going to be 6 different operations it's going to do. Finally, application. What are the type of the application you are having? It may be smartphone. It may be your home automation system. What are the smart application type is there? It's going to take it. This is the difference between your general OSI and also your M2M, that is OSI model for your IoT and M2M. You should see to that one. This image is more than enough. Once you know this, you can easily. People should know that one. Once we not receive. So at the bottom, the statement is given. Generalized OSI layer model. IETF 6-layer structure, and your actual conceptual framework. How the conceptual framework? Data, what is that? First we are going to get gather, enrich, stream, then we are going to get modify, manage, acquire, and organize. All those. These things already we have come across 6 layers. It's going to be. Same thing has been explained in the theoretically it's been explained. I think that's all for today. Yeah. This is smart street light. One more example. Smart street lights diagram. We have discussed smart cities, smart home we have discussed. Smart cities also we discussed. And IoT and MTM OSI model also we have discussed. Modified OSI model. Now, one more example. How exactly street lights are going to work? 6 layers. With respect to the 6 layers, IoT based 6 layers, how these 6 layers will be working with respect to a smart street light. It is one example that's been discussed over. Layer 1. What exactly layer 1 will do? It consists of smart sensing and data link circuits with each street light transferring the sensor data to L2. A street light, smart street light, nothing is there in front of the street light, so this is off. Light is off. Okay. So, Until any obstacle comes, the street light is keep on sending that one. Nothing is there, nothing is there, nothing is there. Like that, keep on sending out. Once any obstacle comes in between in front of the street light, immediately it will sense that one. It's going to send the data to the layer 2. Okay, that is what the information, whatever is sensing through the data link circuit, it will be sent to the layer 2. What the layer 2 will do, it consists of a group of controllers which receive the data of each group through Bluetooth or Zigbee or aggregates and converts the data for communication to the internet and controls the group street lights as per the program command from the centralized station. There are series of lights installed from HTC to Vidyanagara class. Some maybe we will be having some around 10 poles, each 100 meters you can one pole over the other. All are working as smart. So each street light it is gathering the information, sending the information to the next layer, where all of them are controlled by different types of wireless devices like Zigbee or Bluetooth or some other devices. It communicates the network stream on the internet to the next layer. That is streaming. First one is gather, next enrich, next you are going to stream that one. Layer 3 is streaming that one. Layer 4, the transport layer, what the layer 4 is going to be? The transport layer does device identity management, identity registry and data routing to the new layer. It's going to route to the where exactly it should be sent. Data layer 5, the application support layer does data managing, acquiring, organizing, analyzing, all those things what we have explained. It's going to do. And finally, the application layer enables remote program to issue the centralized station direction to switch on or off and commands to the service controlling. So, one example we have taken and we have explained how exactly 6 layers are going to work with respect to the street lights. Similarly, not only street lights, parking system also will be taken care like only. Even hospital management also will be taken care. A patient need to be monitored. Multiple patients are there in the hospital. All are serious. Okay. Some of them oxygen level is going down. Oxygen level is okay. We need to monitor. Or everything is happening manually as of now. So we should check that one the pulse. As the pulse is there, pulse keep on changing over there. And my oxygen level is 90, 85, 80. Should be in the range of 90 to 95 or beyond 95. It's okay. If it goes down, if you have an IoT service for that one, immediately it senses and says that one, this oxygen level is going down, this patient is getting serious, you need to concentrate on that. Immediately, they may send the oxygen. This is one of the best examples I can say. When using IoT, you can go for it. Okay? But even though sometimes manually you are doing, manual what happens now, instead of giving a limited oxygen, they may have given excess oxygen. Limited oxygen they have to give, limited flow, they give the excess oxygen. Because of that, some many patients were dying recently because of corona. Sometimes there is no oxygen supply, patient died. In my case, only 24 people are dead because of no oxygen supply. In one hospital, one of the district hospital, in one day, a single night, manually they are supposed to supply, they are going to supply the oxygen. Series of beds, 24 patients died. If IoT is there, we can be able to manage them. So we need to contribute. It is our duty to contribute for that.